Morning, and welcome to both a talk that I've been looking forward to the entire series and the saddest day because, of course, today is the end of the 2025. So I know, I know. And I have to tell you, I'm gonna let you in on a little secret. Selfishly, spending my Saturday mornings surrounded by curious people who love science gives me just a little bit of fuel for my soul in these days. All right. Just a little bit. So I want to thank all of you. Anybody watch Ted Lasso, the Ted Lasso series? Sorry for the folks on Zoom. Some of you, there's a very famous scene about where he's playing darts. And right, if you've seen it, you know exactly what I'm talking about. But what does he say? Be curious, not judgmental. Right? And I think we all could use some of that. And that's what we do every Saturday here. So thank you to all of you who are here. Thank you to the people around the world. There are people watching all over the world right now on Zoom. Ciao, Elisabetta. I know you're on there. Um, I also need to thank a few more people before we get started. The AV, whether we were at PPL or here, has been just seamless. And so he's hiding. You can't even see him right now. Stand up, Anthony. But Anthony and Harry, way up high right there. I want to give a big thanks to. All the logistics and everything happen because of two people, one who's hiding in the back right now. But can we give a round of applause to Britt Albuquerque? That's you, Britt. And in absentia because she is on vacation after on Thursday, we had 850 middle school and high school young women here on campus for like our 24th. What year was it, Britt? 24th annual Young Women's Conference in Science, Technology, Engineering, and Mathematics. It was unbelievable. And to Dee Dee and Britt, who put that together, and then all of this. One more round of applause. And then finally, the same way I begin the lecture series back in January is with a tribute to Ronnie Hatcher, the engineer who really took what was an idea back in the 80s and in the 90s, turned it into what we have here, and who tragically died much too young. Ronnie was an electrical engineer at the lab, responsible for building some of the most complicated power systems that we create to power up fusion reactors. Just a remarkable, remarkable human being, not just technically, but personally. And so I think about him every single Saturday. Okay. Oops. Yeah, you notice I went quickly past the bagels and the coffee. um, oops, there we go. So I am beyond thrilled to welcome Professor Patrick Murray from Monmouth University to the Science on Saturday stage. Come on up. You can see his bio on the screen. He is one of the country's experts when it comes to both the science and the art of polling. But before we let him speak about that, I of course have three questions to ask him. So welcome, first of all.
My pleasure.
Um, First question, when did you first become interested? Normally I would say science, but in this case it's science and statistics and polling.
Yeah. Um, that's a good question because my first poll, according to my grandmother, that I ever did was when I was 4 years old. Um, she took me shopping. I think we went on a bus into downtown Camden, where she lived at the time. And we sat up front, and I asked everybody who got on the bus whether they liked the bus. Um, I biased the results of my survey by saying that I liked the bus before they got to answer. So I got 100% who said that they liked the bus. But no, seriously, um, it was interesting. I worked for a pollster in Washington when I was in grad school, when I was doing a semester in Washington just for a job. Never thought about it as a career, but my major was government and law, and I ended up going to grad school for political science. And I wanted to do something around political behavior. Um, not sure what it was, and I went to Rutgers, which had a political behavior program. And I should back up by saying when I started going to college, I thought I might be becoming an engineer. So I went to a school that had some engineering, but also a good liberal arts program. And I realized I wasn't interested in just the numbers for the numbers, and I was really interested in politics. And so I went into that, and they didn't really have a quantitative program. It was when I went to graduate school. And I realized that all the research that I was gravitated towards had its basis in survey research and opinion research. And from that, I just started, that's what I did all my secondary research on. And then Rutgers has the Eagleton Institute up there, which has the Eagleton poll, which was one of the premier polls, state polls at the time I was in grad school. And I just walked over there and said, "You got anything for me to do?" And that's how I started.
That's a lovely story.
Yeah.
Okay, so in all of that, tell us about a teacher who had some significant influence on you from whether that is elementary school through graduate school.
Yeah. I mean, I've had a lot of great mentors, and particularly in grad school, starting with Cliff Sukin, Rick Law, and Sue Carroll. But I think the one probably inspired me the most, and this gets back to my story of like I started as an engineer and then went into, I was really interested in government, and then I found something that kind of merged the two interests that I have, or the abilities that I had. One was mathematical and the other one was government. I had a teacher in high school, Sister Mary Ann Jacina. She was in charge of the music department. And so I had her for music theory. She produced all the school plays, but she also taught AP chemistry. And I had her for AP chemistry, which was a little harder than the music theory course I took with her. But the point is that I saw that as something, oh, you don't have to be locked into one identity in terms of whatever your vocation is, whatever yours is. And I think that's helped me. And when I was thinking about, oh, I could do one thing and I can use a couple of different skill sets in a career. So that was really inspiring to me.
And then last question, something outside of polling, outside of your day job, hobby and interests that is just something different.
You're aware of this. So I'm a big history buff, and I'm also a cyclist, not a competitive cyclist. I'm a leisure cyclist. And so I use my cycling to discover history. So I'm like a big American history buff, particularly the American Revolution here in New Jersey, which I grew up in New Jersey, so I'm a lifelong New Jersey, and I never knew what the contribution was to this state. George Washington spent a quarter of his time as commander-in-chief here in New Jersey during the Revolutionary War. And the reason why we know this is because I actually counted it, and I actually told the folks who were in charge of this stuff. I said, "Did you actually add up the days?" And that's how many days he was here. And just the fact that there's a 30-mile stretch here from Rocky Hill up to Morristown, where there are 3 houses that were his headquarters for a fifth of the time that he was commander-in-chief. So when I ride my bicycle around, I ride through little towns, and I find things like, it's amazing. You're in a suburban neighborhood, and suddenly you come across an African American burial ground. So that's what I do. Just travel around New Jersey and look for history.
Well, thank you. Anthony, you're ahead of me. Switching over to the slides, and with that, the science and art of polling, Professor Patrick Murdery.
Okay.
Thank you.
Thank you. Got to remember where I was. So when Andrew asked me to do this, I've watched a couple of the Science on Saturday, well, more than a couple, and found them fascinating because I'm also physics just fascinates me. In fact, about 8 or 9 years ago, I took my daughter to Andrew gave us a tour of the lab when she was in high school, and I just love that stuff. So I thought, what the heck is this audience going to think of me coming in here to talk about science? But if you define science as a rigorous, methodologically based study or understanding of phenomena that exist in the world, I mean, polling is a science. There's a science to it, but there's also a lot of art to it. And there's probably a lot more art than there is science. So let's start by talking about who does opinion research, because this is used quite a bit in the world to help us understand. I just happened to pull out one question here that I thought was interesting, which was about should government officials listen to scientists when they're making decisions? But there are all sorts of different types of uses of polling or survey research or opinion research, however you want to define the term. So for example, this chart in blue shows you all the different federal agencies that use survey research for a whole host of statistical understanding of what's going on in the world. Anything from farm production to the employment rate and job creation to the census, obviously, because the census every 10 years is a count, but between that, they got to keep things updated, and they use survey research in order to do that. We even find that here in Canada actually keeps track, the Canadian government actually keeps track of their use of different types of opinion research in the federal government there as well. All right, so in talking about the science, right, when you're making a conclusion about something, some phenomenon in the world, you're looking for what are your sources of error, and your sources of error are always in a number of places. So to boil it down for survey research, the sources of error come in two key places. One is sampling, because the point of survey research is that you're not going out there and trying to measure the entire population or obtain a measurement from the entire population. You are going to draw a sample because it's more efficient, it's more cost effective, you can do it in a time, and you can draw conclusions from it. So sampling, the way you sample from the population of interest, is one of your sources of error. Another source of error is in how you actually decide to measure what's going on. And that is where survey research has a little bit more leeway than some other forms of scientific inquiry, in that there's a wider variety of acceptable ways to measure, in part because we're not completely agreed on what measurement works best in terms of validly tapping into the concept that you're thinking of. So if we think of, do people support Ukraine, or Ukraine's fight for its survival, however you define, even the words I'm coming up with just to describe that show that there's different ways that you can approach that. And then when you write questions to ask people their opinion, that's another source of error, which I'll talk about more specifically. But let's start with sampling, because that's the more statistical part of this. All right, so sampling is really key because people say all the time to me, how can you survey 800, 500, 1,000, whatever number that is, people, and say that's representative of the entire population of the United States, or even the entire population of New Jersey? There's millions and millions, or tens of millions, or hundreds of millions of people in that population. You've got 1,000, forget about it. How is that going to be statistically significant? Well, we trust sampling in a whole sorts of other ways in our lives, right? So if we go and want to know if we've been exposed to an infectious disease, then they test our blood, take some blood out of your arm, right? We trust that if the disease is present in our bloodstream, that it will be present in that sample that's taken from our arm. We assume that if that pathogen is there, then it's evenly spread throughout our blood, that it's not traveling in different places, then that you have to make sure that you take the blood at the right time when the pathogen is passing through your arm. No, you assume that it's spread throughout the population, and taking a sample will work. You don't have to eat the entire pot of soup to know if it's got enough salt in it, right? So these are ways in which we trust sampling all the time. Um, so let me give you an example of how sampling works, not in survey research, but just in general. And this is the basis of it. So say we want to know how many blades of grass there is in a soccer field. Well, we can go out there and count them. Now, a soccer field is usually about 100 meters by 50 meters. I mean, they vary in size, but let's say it's about that. So that's about 50 million square centimeters of area that we're going to be counting. So you can send somebody out there to count, and in a few months' time, they'll come back and they'll tell you how many blades of grass there is in the soccer field, right? So you got to find a better way to do that. So one thing that you can do is, I said there's 50,000 square centimeters in a soccer field. You can actually overlay a grid of 50 million little squares, and then you can sample from those squares, and then you can count the number of blades of grass in those squares, and then multiply that out. Right? So let's say, for example, that there's 250, somebody did actually do the counting over the course of a year and found 250 million blades of grass in this soccer field. All right, so you want to verify that count. So what you're going to do is you're going to draw a sample. You draw the sample, you'll overlay the grid. You have 50 million squares on this grid. It's 1 centimeter each. You find that there's 5 blades of grass, 5 blades of grass on average in each of those little squares. And of course, you multiply that out, that gets you the 250 million. So you do your count, and you come up with 245 million. Right? Are you accurate or not accurate? Is that close enough? Because what we know is that that's what we would expect to happen. So for example, if we drew a sample of 500 squares, and we came up with 245 million. Sampling is telling us that's what we would expect. We would expect somewhere, if the true number was 250 million, we would expect that our sample to produce somewhere between 245 and 255 million in our count once we project it out, because we drew a sample, and there's a margin of error involved in that sample. And that margin of error is based on how confident we want to be. And if you look at scientific research, you'll see things like this statistic is significant to the p to the less than 0.1 value. That's the 90% confidence level. Or 0.05, that's the 95% confidence level. If you want to be more confident, then you can say, well, I want to be confident at the 99% level. Well, then you have to, that's 0.01%. Then you might say that the actual count is going to be somewhere not off by 5 million, but it could potentially be off. And this is just potential. It's not that's going to necessarily be off, but it's going to be potentially be off by another 2.5 million or so. All right, so about 7.5 million either way. Now, if that's an acceptable level, like whatever you're using this count for, and this is true in science, whatever you're using this count for, is that an acceptable level of precision or not? What your needs are. To give you an example, that happens in medical research all the time, is that, what's your level? There's things that are going to fall outside of that range sometimes, but what's your acceptable level of precision and error? All right, and I'll talk a little bit more on it in just a second. But let me talk about the different types of sampling so you understand when this works, when this doesn't work. All right, so probability sampling. It's what, when you're in grad school, is taught as the good kind of sampling. Probability sampling means that if you have a population of interest, then every individual in that population has a known non-zero chance of being selected into whatever sample you draw. And what that means is that non-zero means they have to have a chance, and known means you have to know what the probability is, but it doesn't have to be equal. Now, there are certain times when we do draw a simple random sample where everybody has an equal chance, but that's not necessarily the only way to do it. For example, you can do something called a cluster sample. We do this with school surveys all the time when we want to survey students. Say we want to survey students in high school. Well, you would need to generate some sort of list of every student who attends high school and then randomly sample them and then send it off somehow to each of them. Another way to do that is to know that high school students exist in clusters. What are those clusters? The actual schools that they attend. That's their cluster. So what you can do is instead of sampling the students, you can put the population of schools into your sampling frame and then sample the schools. And then within those schools that get sampled, every high school student gets interviewed. And then you can project that up. Now, because schools have different sizes, the individual students that you end up interviewing will have different probabilities of being selected. But you will know what those probabilities are because you should know the population of each of the schools that you're sampling. All right, so there are different ways to do probability sampling. But as long as you have a probability sample, you can calculate that margin of error that I was telling about and talk about the range, how close is this to the reality, or how confident are we in how close this is to the reality. Now, there's another type of sampling called non-probability sampling. And this is used a lot in market research. It's not a scientific form of sampling, but it's a useful form of sampling for people who want specific types of information. So to give you an example, it used to be in the old days that you could go to a shopping mall and you might get accosted by somebody who wanted you to take a look at a product or something, right? That just doesn't happen as much anymore. But they might want specifically a product. It's a product that's geared towards families with young children. So if they're in the mall, what they're going to do is look for somebody who obviously has a young child. There's evidence of a young child and recruit them. That's called a purposive sample, right? That they're trying to get that group. And once they gather that information, and they can say, X% of the people that we interviewed like this particular product. Well, you can't take that and project to the entire population of people who fit the profile that you thought you were looking at because you haven't done a probability sample of them. All right, so you can use that if you're a market, if you're a business, you use it because it gives you some idea of what's going to work for you. You don't need to know that it's exactly X% of the population of interest who are going to buy this product. You just know that I'm going to be able to increase sales of this product if I do X, Y, or Z based on the research that you did. I have an example of where we use purposive sample for a public policy issue. So I'll talk about that in a little bit. But I just wanted to give you that example there. So to let you know that there are other types of sampling other than scientific sampling. In public opinion polling specifically, the way we sample has evolved over time. Back when Gallup started, and back before Gallup, the first kind of public opinion polls were kind of these quote unquote man on the street polls, which newspapers would send people out and just say, go interview a bunch of people who walk by the corner, and then we'll report that as we talked to 50 people and 30 of them thought this, liked the mayor, and 20 hated the mayor, and 5 didn't care. So that's one way of doing sampling that happened for a long time, or just sending out mass mailings. There was a newspaper, or a newspaper magazine called Literary Digest, which was the most widely read magazine in the country at the turn of the 20th century into the early decades. And they used to do a survey every election season, of presidential election season, and they sent postcards out to their subscribers, and they got them back, and they report what their subscribers did. Then they decided, well, let's expand this. Let's send it out to people who own cars because they had car registration, people who have telephones because they had the telephone listing, as well as our subscribers. And so what happened was they were doing fine until like 1936, when Roosevelt was running for re-election, and their survey, which got millions of responses back, millions and millions of responses back, showed that Roosevelt was going to lose. Now, obviously, Roosevelt won re-election in 1936, but they got it wrong. They actually went out of business a couple of years after that. But there was a guy named George Gallup, who folks in Princeton might have heard of, who had a different way of doing a survey. He could do a survey with just a couple thousand people, and he used something called demographic quota sampling. So what he did is he took census information about gender, race, age, and different types of living areas, urban, suburban, rural, or they lived on a farm, where they worked on a factory, and he created these profiles of the country, and then randomly selected different areas of the country to send interviewers out into, and had them go systematically capture people of different demographic characteristics. And then that would add up to what they saw in the population, or match what they saw in the population. All right, so that worked for a while, and then you had this big 1948 election where the polls showed Dewey ahead of Truman, and there's a famous headline from the Chicago Tribune of Dewey defeats Truman. The polling industry had to go in front of Congress, very similar to what's happened here in the last 10 years. But they went in front of Congress and kind of said, what was their methodology? I think a bigger part of the problem was that they actually stopped polling about a month before the election. But they were looking at the methodology and said, well, we need to do a different type of sampling methodology. And so they went into address list based, because now they had a better sense of addresses in the US. And so they're still doing in person, mainly in-person surveys. So they would use an address-based list rather than a demographic quota-based list. And surveys basically got back on their feet. Then, as telephones started increasing, the coverage of telephones started increasing, they started moving to telephone survey because it was less expensive to call people on a telephone than it was to send people all the way around the country to do interviews in person. And they started using something called random digit dialing, which was basically, you would get from the telephone company area codes and exchanges, and then you would randomly generate the last four numbers. So you would get listed and unlisted people there. And that worked really well for a while until people started getting cell phones. I remember when I started doing this in the 90s, we were still on this random digit dial process, and we would regularly get 70 or 80% response rates without even thinking about it. Why? Because if your phone rang, you picked it up. You didn't know who was on the other end, and you weren't inundated with spam calls. So you picked it up, and we said, and particularly when I was a student there at Rutgers starting out, and we were calling New Jersey, and you say you're from the Eagleton Poll at Rutgers University, a New Jersey resident is going to talk to you. So we had really good response rates by using that. But then when cell phones came along, and it kind of was a challenge, but we figured that one out too, because now in the digital age, so much of our information is available, is that there are companies out there that can glean all this information and develop these lists. And so we have pretty comprehensive lists. The problem that we have now is not about sample coverage, meaning does everybody have a known non-zero chance of being selected into the sample, but the question is, do they actually answer their phone when we call them? That's the bigger problem, because I said we used to get 80%, 78% response rates easily, and now we're down to 5% response rates. And that's all across the board. Now, our friends at Pew Survey Research have done some work to say, is there a significant difference between a 5% response rate poll and a 50% response rate poll and a 70% response rate poll, if you can get it? And they have found that there's not a huge difference. But the difference might be big enough in certain instances, particularly when we talk about election polls, where people say that there's a problem. And I'll get into that in a second, because that's more about expectations than what polls can actually do. But anyway, from the 2000s on now, we've been using a mix of methodologies that include online panels and so forth. Some of them selected by probability. There are a number of really good panels out there where they recruit some people, and they might have some of the bigger panels have maybe 1 million people on their panel, and that they go to them again and again to do surveys. But they were recruited using probability methodology, meaning they probably used an address-based list to call them or send them an invitation to be part of the panel. So they started with a probability sample to get people into the panel. But there are a whole host of others that are not probability because they're cheap and easy to do. Just recruit people who are willing to get on there and just look and say, okay, what are your demographics, or what's your age, what's your race, what's your gender, and then we'll add it up and we'll try to match that to the census, and then claim that our sample is representative. And it's not always that way. If you see here in this chart, back in 2000, almost all polls were done with a live telephone caller, almost all of them. Now, the number of polls have grown in total number, and this orange area are all these online opt-in polls that are just flooding the market, and most of them are not high-quality polls. All right, let me then recap the sampling portion of this. So when we do a probability sample, we are looking at a margin of error. So we know that when we select the sample, that we have that whatever result we're going to get from the sample will be true if we could interview the entire population within a certain range, whether it's plus or minus 3%. So let's say it's plus or minus 3%, and the number we get in our poll is 63%. That means we are confident that the real number, if we could tap everybody, would be somewhere between 60 and 66%. So we're confident with that. If we can live with that, then that's fine, if that's level. That is the margin of error, say, at 2 standard deviations. That's the blue line. That's 95%. If we wanted to only be 68% confident, which is 1 standard deviation away from the mean, then we would be able to say, hey, we're within 2 percentage points. That 63% is actually 2 percentage points margin of error if we only wanted to be 68% confident in that margin of error. If we wanted to be 99% confident in that margin of error, that same statistic, then we'd have to say the margin of error is plus or minus 4%. We're within 4%. We're 99% confident that we're within 4%. Now, what you see is most polls report the 95% confident level, the 2 standard deviations. So when you see a poll reported, they'll say it's plus or minus 5%. They're calculating that 5% using the 2 standard deviation standard. So to give you an example of that is that here is the same polling done there, but at different results. Let me back into this again. This is the formula for calculating margin of error. And the P is the proportion estimate. The proportion is what's the result you're getting from, what's the mean you're getting from your population, or from your sample, excuse me, from your survey. Is it 63% or 0.63? Is it 92% or 0.92? What's the result? So that gets calculated into this. And then your sample size, your population size, and then the confidence level. As I said, this is a constant based on those standard deviations. If you're going with the 95%, the 2 standard deviations, then the constant is 1.96. And that gets plugged into the formula. Then what we see when we look at this is that I said the proportion estimate here. The proportion estimate is if it's a 50-50 split, like 50% say yes, 50% say no, or if it's a 90-10 split, 90% say yes, 10% say no, you're going to get different margins of error. the more extreme the split is in your percentage, the lower your margin of error is. And so when you see that plus or minus 5% reported for a poll, they're reporting it if, hypothetically, if the result was 50-50, because that's where you're going to get the largest margin of error. But technically, you should calculate the margin of error on every single statistic that you calculate. That's just too cumbersome to report. So what we usually simply report is the 50-50 split and just assume everything's, that's going to be the max that it's possibly is. The other thing that I wanted to point out in this formula, going back to the question that was asked of me, that's asked of me all the time, is how can you do a sample of 1,000 and out of 300 million people and have that kind of confidence and that the margin of error is that small? This is statistics. I can't do the proof myself, but here it is. Look at this denominator. That's the population size. That is the sample size. If you calculate this out for a variety of different populations and a variety of different sample sizes, you'll find that this population correction, n-1 and n-n, basically converges on 1. Which means population size doesn't matter. The only time this matters is if you've got a really small population. By small, I mean less than 10,000. So if you're doing a sample of 500 out of 10,000, it's going to affect this denominator a little bit more. But if you're doing 1 million or 100 million, this denominator is going to be almost the same. It's simply based on your sample size and not on your population. And that is a statistical proof, and that's how you can do that. Here's the problem with polling. So that works when we're counting blades of grass in a soccer field, and that's because the blades of grass can't refuse to be counted. So they have to be in the sample. If you pick them in the sample, they're stuck. They got to be counted. The problem is when we draw a sample for a telephone poll or any public opinion poll where everybody has to participate, is the sample that you initially draw, some of those folks can refuse. And in fact, as I mentioned, most of them refuse. The vast majority of them in the initial sample that you poll refuse. Then you have to select additional sample to replace the people who refused over and over again. And as you do that, that introduces more error into this margin, potential error into this margin of error. And that's one of the things that we face here. It's especially problematic with election polling because we're violating some other principles, which I'll talk about at the end. All right. That ends the science portion of this lecture. Now we're into the art portion. And I should say, it's not entirely art. I mean, here's just an example of different ways you can measure some business stuff here, right? But we do have some standards of practices about what you should do in a question and what you shouldn't do in a question. How you bias a question, how you don't bias a question. And that's, in fact, many times when I'm talking to reporters or I'm talking to people who are paying attention to polls, particularly on policy issues, I say to them, I'd pay less attention to the sampling error and more attention to the measurement. If you don't know how the question was asked, you don't know what they really might have been tapping into. To give you an example of this, there was a question asked by Quinnipiac and Marist in New York City. And this was about bike lanes. All right, so this is going back 10 years before they had bike lanes in Manhattan. And they asked New York City residents whether they wanted bike lanes. And Quinnipiac came up with a 60% said yes, 30% said no, and 10% said they didn't answer the question. And I don't have those numbers exact, but that's about what they came up. Marist came up with 40% said yes, and close to 30% said no, which meant 30% didn't answer their question. So is it 60% or 30%? And the key difference there was that Marist actually included in their question wording when they were talking to people on the phone, do you support or oppose, or don't you have an opinion on it? whereas Quinnipiac only said, do you support or oppose? So some people said, look, I really don't have an opinion, but other people who probably didn't have a strong opinion just said, sounds like a good idea, and said support. All right, so that was one issue. The other issue was the way it got reported, which was on the Quinnipiac poll, the headline was, New York City residents demand bike lanes. That's not the concept they were asking. Look at the question. It said, do you support or oppose this? Even if that 60% number was correct with support, support does not mean the same thing as demand. And that's the key, that you have to look at how questions are asked to know what concept of public opinion they were actually asking. So let me give you some examples of some ways that we've used question wording to give a better understanding of what's going on. So one of the best ways to a question is find questions that have already been asked and tested and have a track record of reliability. Even if you're not sure what concept they're, you might have an argument over were they really tapping into this concept or slightly different into that concept. But if it's reliable over time, at least you have a sense of comparison. And that's a key thing for survey research. So I did a study a few years ago after Superstorm Sandy hit. We got a grant to look into communication issues around this. And the grant was basically just, we want to find out those who were hardest hit by Sandy, that had their homes destroyed or rendered uninhabitable, what was going on? How did they learn about what things were available in terms of support? How did their town communicate with them? That was really it. But we wanted to do it a little bit more. And by the way, we used a purposive sample for this. Because the research question led us to say, well, we don't need a probability sample would be very expensive. And it probably would be very difficult to get in touch with these people using a probability sample of everybody. We'd be missing a lot of them because a lot of them, their phone service was off or they're around. So what we did is we went knocking on doors, putting on door hangers of places that had been hit, going to town meetings where these people we know would be gathering because they wanted information. And so we recruited, I think we recruited close to 2,000 in the beginning to participate in this survey, which we did online and by telephone, and then we followed them over 5 years. And that was the key, is that we were able to follow them over 5 years to see how this particular group navigated the system and what hiccups they saw. So we could report back. By the way, there was a governor at the time who wasn't happy with us doing this because we were pointing out all the problems that people were facing. But one of the things that we wanted to look at was also their well-being. And so what we did is worked with some psychologists to look at what standard measurements are being used out there right now that we can use with this population that would give us an idea of how they were doing. And so this is something called the Kessler-6 distress scale. And this is how the scale works. And this is actually also used in diagnostic work in psychology as well, where they have people fill this out just to give it a sense of whether they might need some attention for distress individually. But this has been used in a wide variety of places, including the behavioral risk factor surveillance system, which is done by the US Department of Health in every state. And they said during the past 30 days, about how often do you feel nervous? And then here are the answer categories. And what you do is you take those answer categories, what they answer, each is assigned a number score, and then you add up those numbers across the 6 different aspects of life that we ask about, and then you arrive at a score. And then there's an agreed upon cutoff for that score of whether they are in significant distress or serious distress or mild distress or no distress at all. So we have the ability to use these benchmarks, and you can see that started off with only 53% saying that they had no distress in 2013, and then it went up to 68%. Those who had serious distress went down from 25 to 15 over that time. So we did see some improvement. But one of the things as I mentioned, is that we also had measurements for the entire state of New Jersey from this behavioral risk factor surveillance system. So we know that even here, this number who said they were having serious distress was significantly higher. Now, you may make an argument that says, this doesn't measure stress, or this is not measure stress the way I think of stress, or if you use different questions, you're going to get a slightly different answer to this or slightly different percentages. But the point that we have with this is that the key aspects for measurement are, is it reliable and is it valid? So you might not agree, you might have differences agree on the validity, but this has been tested over time, and people say this is close to being, as close as we can agree to being a valid measure, meaning it measures what's the concept as we actually think exists, and more importantly, or just as importantly, it's a reliable measure. It's a measure that measures it the same way time after time after time. So if you measure it with this population, and I measure it with that population, we can compare those results to see the difference. And that's a key. That's a key part of measurement. Now, I mentioned something about non-attitudes, and here's a way, this is that example that I gave you, but in a different format. This has actually been tested. Somebody made this up. There's no such thing as a one nation policy, yet when this was asked on a poll some years ago, it got people to answer the question whether they support or oppose it, right? So you got to ask them whether they've heard about something first, and then you ask them whether they support or oppose it, or if they have no opinion. Better way to make these measurements. And that goes back to those little guidebooks that I should call them little, but some of them are actually like, almost biblical in how they're used in our industry in terms of the standards that you use when you're creating questions. But let me give you a real life example of where it doesn't make sense at first. So this is going back 2008, when Frank Lautenberg was our US Senator, and he turned 84 during that reelection campaign. And our friends up in Connecticut at Quinnipiac asked, do you think Frank Lautenberg's too old? 54% said yes. Banner headlines. New Jersey voters concerned about Frank Lautenberg's age. I wasn't so sure about that. So I asked the question, and I only got 34%. And I consistently asked the question, they consistently asked the same question, and I consistently got a lower number than they did. So what's going on here? Both of these can't be right. They're too far apart. This is not just margin of error stuff. This is way too far apart. So remember, there's two sources of error. One is sampling. Are we interviewing the same people? Well, there's a way to figure this out. Let's look at some of the other questions from the poll to see if they are different. Now, what are we concerned about with this kind of question and this kind of poll? Well, partisanship could be different, right? The Republican Quinnipiac poll could be more Republican in their sample. The Monmouth poll could be more Democratic in their sample, and therefore that's why we're getting this difference. So let's look at a different question that taps into partisanship, which is, will you vote for Frank Lautenberg? Well, the two polls are getting almost identical results. So it's not the sample that's the source of the error for this. Let's look at how the question's asked. Do you agree that Frank Lautenberg is too old to be an effective senator? That's the Monmouth question. The Quinnipiac question. At age 84, do you think Frank Lautenberg is too old to effectively serve another 6-year term as United States Senator or not? All right. Now, before I started asking my question, I saw Quinnipiac's question, and I talked to some of the reporters who were running these headlines. I said, it tells people what the age is. And they were saying, well, what's wrong with that? That's factually accurate. I said, that's factually accurate in terms of Frank Lautenberg's age, but you're reporting that the public is concerned about his age being 84, and we don't know whether that is factually accurate. So what did we do? I did some experiments. I asked my base question, then I would ask, what about an 84-year-old? And I asked my base question, I would ask, how about Frank Lautenberg 6 years from now? And when I did those questions, I got a 15% bump when I mentioned his age. I got a 7% bump when I asked people to think 6 years ahead. Turned out I got 53% when I added those two bumps together, almost identical to what Quinnipiac was getting. So what was going on here was my question was, if you know what Frank Lautenberg's age is, you're answering this question based on that. If you don't know what his age is, or you think his age is different, you're answering your question based on that. If you're answering it based on what you think his age is now, then you're answering the question based on that. And if you think about the way Frank Lautenberg will be, what his old age will be in 6 years, then you can answer that question that way. But in this, you have to answer the question based on those two concepts. And in fact, we asked people what Frank Lautenberg's age was after we asked them, and his average guess was almost a decade younger than he was. And why does that matter? Well, if you think he's in his 80s or even in his 90s, you think he's too old. But if you're like most New Jerseyans and think he's less than 80, very few of you think that he was too old. And so when you're thinking about what are you actually trying to measure? So Quinnipiac actually measured hypothetical opinion. Hypothetical was, what if everybody in New Jersey, every voter in New Jersey woke up one morning and knew that Frank Lautenberg was 84 years old? Then, majority of them would probably be concerned about his age. But if you're actually, and this is the argument I kept getting into with the media, if you're actually concerned about what will happen in November when people go to the polling booth and what will they be thinking in their head, you have to ask without the added information to get a true read of what extant existing public opinion is. All right, so that's one thing that you gotta be careful with. And again, everything here was factually accurate in terms of the facts of the case, but not factually accurate in terms of reflecting public opinion as it existed, because it added information that people don't have. When we measure public opinion, we're measuring three different components: knowledge, attitude, and behavior. And there's different ways to do that. In this case, it didn't measure knowledge, it injected knowledge in there. All right, let me give you an example of a deliberate polling bias. Look at we are on time. All right, so let me, and I'm going to wrap up in a bit here. So deliberate polling bias. If you back 2002, so we're going over 20 years. If you remember, there was a threat of a boycott of the Masters tournament, which is held at Augusta National Golf Club. They didn't allow women as members. There was concern that some of the advertisers would pull out. CBS would pull its contract. The PGA would be forced to move the tournament to another course. So the Augusta hired a pollster. Happened to be a pollster that I grew up in South Jersey. She's a couple years younger than me and grew up just about 10 miles away from me. Now, we never met as kids, but the pollster who did this poll was known for doing this women trends study, and so that's why she was hired to do this poll. There's a reason why I'm telling you that information, and I'll get to it in a second. So here's the poll. A lot of information in this question. Most people haven't even heard of this, so they did ask that at least. Have you heard of this debate? And most people hadn't. But then they said, they don't get federal funding, she's demanding this, whatever. Should Augusta be able to keep its male-only membership? And 62% said yes, 30% said no. So already you got some bias in the question and wording, but the bigger bias was, this wasn't the first question that was asked. The first question that was asked is, the First Amendment of the United States Constitution applies to everyone regardless of gender or race. Do you agree with the First Amendment of the Constitution? Then it asked, should single-sex colleges be able to exist? And it asked about the NAACP. It asked about Boy Scouts and Girl Scouts and all sorts of things. So by the time that you got to this question, if you said Augusta shouldn't be able to do this, you were against mom, apple pie, and the American way. This was a deliberate attempt to bias. Now, what was interesting, the reason why we know this is because the results were actually released with all the question wording. And the person who released this, and it got shot down by the polling community for the obvious intent to bias the results. And the person who did this said, this can't be biased because I released all the question wording. Now, the person who did this poll, and I've been using this as an example since 2002. And as deliberate bias. The person who released this poll was somebody by the name of Kellyanne Conway. So I had her number on the alternate facts deal long before she hit the national stage. Yes, so it was fun when she hit the national stage, and I've been using this in my lectures for 20 years. That was something. All right, so let me end with talking about this special case, which is election polling, so we can get to questions here. Um, Election polling. So I've talked about sampling, I've talked about measurement. Okay, I talked about sampling. A probability sampling is that every element of the population has to have a known non-zero chance of being selected. But I've neglected to mention, you have to know who your population is before you start polling. So when you're doing a poll for an election, who's the population of interest? People who vote in that election, right? But we're polling before the election. The population doesn't exist yet. So right then and there, we're violating the first premise of probability sampling. So what do pollsters do? Well, they come up with these things called likely voter models, which aren't sampling. They're guesses at what that population might look like, right? So already there, putting measurement aside, you're already violating proposition. The fact, though, that they've worked basically well, these likely voter models over time, is a testament to how good most pollsters are. But as we know, there has been a small but systematic bias in one direction over the past few years because of a growth in partisanship, which is impacting a whole host of other things. So let's look at this special case. All right. First, I want to talk about expectations. So let's look at something that we were polling on that was really important, which was COVID. We wanted to know what the uptake rate was for vaccination was, but we also wanted to know those who weren't taking up the vaccine, what were their objections? So we could help inform health providers about different ways of overcoming those objections. But the key here that I want to talk about in terms of comparing this to election polling is, what is an acceptable level of error? So what we were getting in these polls, and this is based on the May 2021 polling, and Kaiser and Ipsos both had polls out at that time. They had the vaccination rate at 62%. The CDC estimate at the time was 57%, and that was a revised estimate. That kept going up and down. So there might even be error in the CDC estimate as well. In fact, I'm sure there's some error in the CDC estimate. But you're off about 5 points. So what was the conclusion when using this data? Because how was this data used? This data was used to kind of get a sense of what the movement was in the vaccination rate and what was holding people back. So the fact that the polls were slightly overestimating this, and there was about 5 points based on the CDC estimate, was they were a little high, but it was basically accurate in terms of what we wanted to use this for, right? Now let's look at an election poll. The polls were showing basically tied. You look at the polls, it was basically tied. Many had Harris up by a point or 2 points, and some had Trump up by a point or 2 points. And the polls were saying it's basically tied. It could go either way. Trump won by 1.5 percentage points. What was the conclusion? Polls were wrong. This is fine. This is wrong. And that's kind of this is the challenge, the battle that we're facing right now. And it's gotten worse. Because this would have been fine 10 years ago. It's not fine anymore. So let's look at an example from here. So let's look at the key states, like the swing states. If we look at this, I think 15 or 16 swing states, the absolute mean in 2016, the absolute error was 2.7 across those states. It was also 2.7 across those states in 2012, but in 2016, the polls were wrong. The error is the same, but the polls were wrong in 2016, not necessarily in 2012. Here's why. What were our expectations? The polls in 2012 were off in Florida in a way that had the wrong winner. It had Mitt Romney winning and Barack Obama won Florida. The deal why we didn't think about that as being wrong is because when you added up all the other states, Barack Obama was ahead in the Electoral College. So the fact that he got a few more votes in the Electoral College doesn't matter because there was already an expectation that he was going to win the Electoral College, even though overall the error is about the same here. But here we had 3 states where it looked like Hillary Clinton was going to win the Electoral College vote, and she didn't because she lost those 3 states, right? So there was a huge polling failure, even though the error was not significantly different overall. Look at this. We had Trump at the average of these aggregates was 0.4. Problem with this is that the media reports aggregators, people who take polls and add them up and come up with an average, as polls themselves. And they're not, because what you say is, oh, then we know exactly what's going to happen here because the aggregators have it exact. No, what you need to look at, forget the average, look at this. What's the range of possibilities that could happen? Because that's what the polls are telling us. You should be looking for an expectation of something coming in somewhere around there. But we don't do that. Because one of the problems with polling aggregators is it has given us a false sense of higher level of precision than actually exists. They don't do the job that they should do, which is say, here's the range of possibilities that could exist, which exist down here. All right. I tried to do that. I stopped doing likely voter models. And I started asking the question a different way. And so here's my Pennsylvania poll right before the election. So we had definitely probable Harris voters at 46%, definitely probable at 47%, but that's among all registered voters. That's the only population that I knew existed. I know registered voters, but we do know that not all registered voters are going to go out and vote. So I'm going to tell you what all registered voters would do if they came out and vote. But because you're interested in what could possibly happen, I'm going to give you some examples based on reality. So this is based on people who said they were extremely motivated. This is based on people whose voting records indicated they voted in the last presidential election. This is if we only looked at the vote intent of people who voted in the midterm prior to that. We think that somewhere in this is the reality of what will happen. And that was true. I mean, Trump won by 1.7. This, and in fact, over the other places that we polled to, the 2020 vote came closest to looking like what would actually happen in reality. But, it would have been slightly different if it was only limited to high and moderate, people who indicated they were high and moderate turnout likelihood. That's the better way to tell you because it gives you a range of possibilities. Because any of these could have happened. So it only took a slight difference to change what the outcome was. But if you saw this poll, you should have been ready for the eventual outcome if you interpreted it correctly. All right, so I'm going to skip that and go to this. So the problem that we have, people don't trust the media. And the reason why they don't trust the media is because of the way the media reports on polling. We did a study from our 2022 poll when we stopped doing typical horse race and we stopped doing likely voter, and we wanted to see how the newspapers. So we had our students do a content analysis of the coverage of our polls online and on TV, and what we found is that 72% reported only the vote question. We asked 37 issue questions, 26 questions on other related topics, just 4 candidate vote questions, but 72% reported only on those. They didn't report on any of the context questions about what was going on in the election, what people were concerned about, what really drove them. So it's not just pollsters having a problem here. It's like we're giving media the content about putting this election in context, and the media is refusing to do that because what they want to do is predict what's going to happen, not explain what's going to happen or explain what could happen. Right? And that's having an impact in other areas that we poll. So, just look at this. What's your current financial situation? Are you struggling, stabilizing, improving? So we're seeing these numbers, change with the economy change. But underneath this, we're seeing significant changes in partisanship. So while the numbers, if we look from June 2020 to June 2021. So this is going from the first Trump administration to the Biden administration. You don't see a lot of change from one to the other. But when we looked underneath, we saw wholesale change among Democrats and Republicans. They flipped. The Democrats went from struggling to doing okay when Biden took office. And Republicans went from doing okay to struggling when Biden took office. And those two changes, which were big changes, even canceled each other out. So the overall movement doesn't look like there's any movement here. Now, in reality, did Republicans' lives suddenly get worse and Democrats' lives suddenly get better? No. The problem that we're having, even when we ask a question that seems to be not tied to politics, such as just tell us how your family is doing financially, are now tied to politics. We're in such a hyper-partisan environment that it's becoming more difficult for those of us who are measuring opinion on public policy issues to get answers that are not connected to one's partisan tribal identity. It's getting bad. And I'll end with a final example here. Oh, and this just shows you, we asked a question about what's important to you, is that we have Republicans and Democrats living in different worlds about what issues are important to them. All right? So that's like, you can't even talk to each other about, because you're not even looking at the same world in terms of saying what's the top problem. But here's where I want to end with an idea of an issue that had incredible bipartisan support just 15 years ago. And that is developing offshore wind here in New Jersey. This is a poll we did in New Jersey, and you can see it's about 80% or so, Democrat, Republican, Independent, and stayed that way. Slight drop off over here in 2019, and a huge drop off among Republicans, pretty sizable among independents. And when we drill down a little bit, it's among Republican-leaning independents, and then steady among Democrats. Okay, so how do you go from strong bipartisan support here and then suddenly dropping off here? What happened between 2019 and 2023 that made Republicans think that wind was wrong? Was there something intrinsic about the development of wind? One thing you look at, do they all live on the coast? And we're worried about things happening on the coast. That's not true, because this number dropped similarly among inland Republicans and coastal Republicans in New Jersey, whereas the Democratic number stayed the same among inland Democrats and coastal Democrats. So it's not about that. It is absolutely tied to your partisan identity. So when you get to a point where it says that in order to claim this partisan identity, whatever it is, you have to abide by the orthodoxy of beliefs of, this or that, you got a whole bunch of people who had to change their opinion about this in order to stick that, because it wasn't their opinion about what was good or what sounded like a good idea that was driving their partisanship, or that they could divorce from their partisanship. Their partisanship is now driving how you have to hold an opinion on different policy issues, which is a problem that we face, not just in measuring public opinion, but in dealing with the challenges that democracy faces today. Fortunately, I'm ending on a really bad note here. But I just wanted to prepare you. This is the truth-telling part of this, is that, this is what we're facing today. Public opinion is revealing this. When we start driving in these numbers, we're telling people that this is what's going on. So I've been doing a lot of work on things like understanding authoritarianism. We have talking about psychological scales. We have scales that we've been using for authoritarianism, trying to get a better way of how do you crack into this. Maybe you don't get the authoritarians, who are about 30% of the population, but maybe you get the next 20% who don't think that that's something that you really have to worry about and make them work. So those are things that we're looking at right now. All right, so that's all I have to say. Questions?
Thank you so much. So we've got microphones coming out. Of course, I suspected we were going to see an enormous number of hands. So be patient. Please wait for a microphone, and we'll go from there. So Patrick, right in front of you.
I thank you very much for a very interesting lecture. Have you ever looked at, when you're measuring on samples, the effect of gender of the person that's asking the question?
Yeah, yes. That's interesting. I used to work with somebody at Eagleton. I'm sorry. I used to work with somebody at Eagleton named Janice Ballou. That was her research question. So we always recorded the gender of the person who was doing the interview. And that was a concern early on, like when when Christy Whitman was running for governor and so forth. That hasn't been my research question, but there is a whole body of research out there on that particular issue. One of the things that, if I can turn your question into a different one, which was about race, is that there was a concern this was in California, the Tom Bradley effect. Tom Bradley, the mayor of Los Angeles, was running for governor, African American. Polls showed him doing slightly ahead, and he ended up losing that governor's race. And there was a concern that people were unwilling to say that they were not going to vote for Bradley, or felt they had to say they were voting for Bradley if they thought the interviewer was black, was African American, and then recorded whether the interviewer was African American or not. We've done that too, particularly when Barack Obama was running for president, just to see if there was an effect there, and there was a slight one. We did see a slight effect if it was somebody who's and the problem is with gender, it's a little easier to tell over the phone, but with race, it's a little harder. So we aren't really recording whether they sound this way to the person, unfortunately. But we just used whether they were or not the interviewer, and did still found there was a slight difference.
Right, go ahead, right one row back in the middle.
Thank you. I'm really interested in the topic of tribalism and how it relates to sustainability, but I'm interested in what your thoughts or research has been with regard to people's sources of information and social media versus fact-checking news sources. And have you looked into we know the trends, and
Yeah.
And the other kind of corollary is we can't stop people from lying on social media and news sources. That's a part of what I understand from journalists, free speech. You can lie and there's no consequences.
Right. So yes, I have, and not as extensively as others have. The Pew Research Center is actually a really good place to go for. And I've mentioned the Pew Research Center before. And in fact, if you're interested in public opinion polling on topical issues, I highly recommend you getting on their mailing list or the email list and just going on their site. Pew Research Center is really the platinum standard for this kind of work. So to your question, yeah, I mean, we've just seen this just change significantly. It's funny. I said we've seen an increasing distrust in the media. That's why there's distrust in pollsters too. We're part of that establishment, those institutions in the public's mind. And as that distrust has increased, the people who are more likely to distrust are more likely now to turn to the least trustworthy sources of information. And we find that when we ask them. They're getting their information from social media feeds, which are curated to have one type of message. And that's problematic. I mean, and I can't comment like on the whole policy thing, but we can go back to the fairness doctrine and all sorts of things about what the media should be able to report or not report. But we are well beyond that. Technologically, is just you can't put that genie back in the bottle from the 1980s. There's no way to bring Walter Cronkite back. It's just not going to happen. So how do we deal with this misinformation system that we have right now is a huge challenge.
Thank you for a great talk. What is the likely impact of AI, either writ small or writ large, on polling?
Okay. So the AI developers are really trying to sell us on this. And so when we test things out, they don't work. So the one thing where we found AI helpful is like when we do a polling or focus groups where we're collecting a lot of verbatim information, not, check, do you agree or disagree, but in your own words, what do you think? And that happens a lot in their focus group work, but we do a lot of online work where we ask that because asking people to talk in their own words helps us generate questions for the future. We say, oh, this is something we weren't thinking about that people are concerned about. It's an old way I used to do this is, particularly here in New Jersey, when people would discuss politics openly, is to go in diners and eavesdrop, and then you'd hear how people talk about things. But AI is good for taking that information and sorting it and giving an idea of like what categories are popping up. Where the AI is not working yet, and where they're trying to sell us on, is creating virtual respondents. Yeah, so that's something that's in the pipeline right now. I don't know of anybody who's using that. I know one or two have tried it and found it failed miserably. And it's simply because you have to think about all the energy that's needed to generate AI, and then all the information that you would need to concatenate a variety of different personalities and the way they answer things. And remember, we could do a poll, and we've done this, where we called somebody and then we called them again like a week or two later and got different answers to some of the questions. They're in a different mood, right? And so AI can't capture that yet.
In Iowa, a respected pollster went out of business after being threatened.
Got sued.
Sued,
Yeah.
well, sued, but threatened with
Yeah.
violence,
Yeah.
and so she quit. What does that say to the future of political polling in this country if the pollsters fear that they are going to be threatened and their families threatened?
Yeah. Well, I don't think pollsters are alone in that. We just saw some reports, law firms, like the law firm that was working with Jack Smith, the special investigator on his investigation into Trump. So the private law firm that was working with that had threats and had their access pulled, and they couldn't talk to government. They couldn't even walk into government buildings. None of the lawyers were allowed that. And then, a judge said that suspended that for at least temporarily. So I think pollsters aren't alone. There's a whole host of folks, and that's problematic across the board if people are going to stop doing their job, whether it's pollsters polling the truth as they see it, and I don't mean as they see it in terms of their opinion. I mean, doing their job, or a lawyer feeling free to give a vigorous defense of somebody who might be on the outs with whoever's in power. All those things are definitely problematic. I don't know how that's going to get handled, but your question should be a wake-up call for folks across the board.
Okay, so my first question is what was it? Why don't you ask people when it comes to voting how likely they are to vote to figure out whether they're an actual voter?
We do ask that question, but if you use that as written in stone as accurate, you're not going to get an accurate answer. In fact, we've done that. So what happens, what do we do? Is that we do our polls, we ask a bunch of questions. One of those questions is how likely are you to vote? Others, how motivated are you to vote? Other things that we use are their past voting history, which we have already from their voter registration data. So they don't have to tell us whether they voted in the past. We actually know that. And then, so we've done a result. And we found that among those who say that they're likely to vote, very likely to vote, about 20 to 30% of them don't vote. Among those who say they're not likely to vote, about 20% of them actually show up and vote. So you have to come up with another way to do it.
Hi. You seem to imply that in aggregating the results across multiple polls, that really only informs on the spread and not so much on the central result. But in the medical field, they always do meta-analyses, and those are believed to actually inform on the central result, not just on the spread of the data.
Yeah, I think it's a fair point, but we're using this information differently. So when medical field uses metadata on these things, they're using it on events that have already happened. You know, that we've studied this. This is the result. This is what we've observed. Whereas this is a model of what could potentially happen in the future. It's like an economic forecast, right? And so anytime you're doing it, something that involves a forecast, you should focus more on the range than you should on the central point.
Two questions. First is your last slide, that why the Republican support of wind farm offshore has this precipitous drop after 2019, while the other two remains the same. You know which one I'm referring to?
Yeah. So
Okay.
you're asking why that happened?
Why? Is that a polling error or was it
No.
real attitude change?
No, it's what I said is that it's partisanship now drives your opinion. You can't have an opinion that is outside the orthodoxy of your partisan identity, or you get kicked out of the tribe. That's what's driving people's the way. And that's why I'm saying this is what's a problem with us measuring public opinion, because in many cases we're simply measuring partisanship, regardless of what we ask about, because life has changed in the United States.
Okay.
You can't veer from the party's hymn sheet anymore. And still call
The
yourself.
second, yeah, I'm sorry, go ahead.
Go ahead. No.
Okay, second question. Your title is says polling science and art. I do not see why can you claim it's anything related to science, because science, we live on it by its certainty. Water freezes at 32 and below. And here you lived on the science word by use of a Gaussian curve. Then whatever you do not know, you attribute to 1 sigma, 2 sigma, 3 sigma. How do we tell that this is just a hide away from real that we do not know, period, as we do not know many things of science itself?
So, got an answer for you. I have a friend who's a playwright, good friend. Got in a big argument. I took my family to see The Mousetrap in London, the Agatha Christie thing, which has been running forever. He thinks it's just nonsense. Go see that. How could you go see that? It's not theater. Well, it's theater. It's a show. It's in a theater. It may not be theater, but it's theater. So it's not science, but it's science. All right.
So if we get approached to do a poll, any suggestions for us on how to tell as we either right at the outset or as we go through it, hey, this is legit, this is kind of priming the pump, feeding me the answers, and how should we react? Should we just stop doing the poll? Should we mess with it? What do you suggest?
It is problematic because the point of polling, and I gave you some examples of where we're using polling in other areas that are really, really important for understanding what we're doing. That Sandy stuff was really, really helpful in understanding how service providers could meet those needs. We use it all the time. And medical research uses this in understanding behavioral factors in the spread of pandemics, for example. But the thing that you see all the time are these election polls and this political stuff, and that's where it's problematic because that's the field that's flooded with bad stuff. The other stuff that we're doing behind the scenes that you don't see, the only people who are willing to do it because it costs money to do, it takes resources, are the ones who do it legitimately. But when you see stuff, this is what I always say, is look at who's doing the poll, for one thing. And there's certain pollsters who have a reputation, and so you want to use that. Unfortunately, the 538, the site that used to rate polls, has been taken down by ABC News, so you don't even have those ratings anymore that you could go to and look at that. They were the one place that did that. But the other thing, as I said, is that do you see the question wording? You don't see the question wording, just ignore it, because you don't know. And I don't trust, quite frankly, I don't trust reporters to interpret the question wording correctly either in media. That's why I always want to see it. Have a link. If they don't report it with a link to the actual questionnaire, then I just have to dismiss it out of hand. Unfortunately, cable news and whatnot just loves, Trump's opinion is the favorable rating has gone up, gone down 2 points, whatever. What I see in all the polling that's out there, the country is evenly divided and continues to be evenly divided. Is it 52-48 or is it 48-52? Doesn't matter. Evenly divided. That's what's going on right now.
Me? Okay. Thank you so much for this talk. So this question's kind of related to the last one, and you talk about biased polling. Do you think that biased polling is a big issue, and do you think a normal person can notice if a poll is super biased towards one political side or another?
No, because you usually don't see huge biases. Usually the biases are small. Small enough to drive it. And this, again, we get into this perceptions issue. A movement of 2 points is blasted across the cryons of all the TV cable networks. Movement of 2 points is nothing. But because there's that level of precision that has got attached to polls, is that somebody who wants to bias a poll doesn't have to move it too much to generate a headline. And that's the problem, is that you don't know whether it's a legitimate, honest margin of error issue or somebody was really pushing the needle. That's unfortunate. Yeah, sure.
So along the same lines as the bias polling, going back to your example of the Frank Lautenberg slide, when you were talking about, even though the distinction that you made in the Monmouth was to still ask if Frank Lautenberg was old, would it have changed the results significantly had you just simply asked, is Frank Lautenberg an effective senator? And then a follow-up question, if necessary, is what do you think, how would you change your answer if you knew that he was now old or even gave an age of 84 or whatever?
Or let me give you a different question. Is there anything that concerns you about Frank Lautenberg being effective as a U.S. Senator? That's one way to do it. And yeah, it would have been different. I don't think we would have even got 31% who said that they were concerned at that point. Or we might have gotten 31%, but we might have gotten a different range of answers to that question. But since old was there, we asked it. But you're right, is that we asked the question, so we might have primed a few people to even think of his age that weren't even thinking of it at all by simply just mentioning his age. Certainly not to the extent that Quinnipiac did.
And in your sampling, when you were talking about essentially trying to draw a random sample, how does persistence come into when you were talking about the Kessler 6,
yeah,
and people are answering whether they were nervous or whatever, if you ask the same people 10 hours later, would they have answered completely differently than the same exact person? How do you measure that kind of persistence?
Yeah, that would be unlikely to be significantly different, but it could be slightly different. And we've done that. We've seen it. The point of, and this is why these psychological batteries are created, you have to answer across 6 questions. So if you answer one of those questions, and this is what we've seen, one of those questions slightly differently, it's unlikely to change the overall conclusion that we draw or your score on that. And that's why, the psychologists love to do 20 questions. That's like way too many. And been working with psychologists on authoritarianism and saying, you don't need these 20 questions. I keep testing this over and over again. These 5 questions keep producing the same reliability over time as we test them than your whole 20 questions. But we still need the 5 questions, because if we only asked one of them and their answer changed on that one, that could change the results. But across 5 questions, it's unlikely.
Vivian, you got the last word.
Hi. Thank you. It was interesting. Going back to sampling, you mentioned in passing that there are people who don't answer the survey, don't answer the phone, and so on. What kind of effect does that have on your sample, though? What kind of bias do you assume, or how do you fold that in?
Right.
I have something else that you don't have to answer after you answer that.
All right. So as I mentioned, the Pew Center did some studies on whether the response rate really has an impact. It has only a minimal impact if, as you're replacing the people who don't, and this is why we're now using listed sample, like voter lists, where we have a whole host of information about them. We're actually moving back in many ways to the original George Gallup sampling method in basically stratifying our sample in different demographic categories and making sure that each of those strata have the right proportion, right? In doing that, so that the response rate isn't as effective. The lower response rate will have some impact on the results, and that's why I say, if your level of precision that you need is 1 or 2 points, then polling ain't going to be working for you. But if it's 3 or 4 points to measure people's opinions about a certain thing, or their behavior about a certain thing, their knowledge about a certain thing, if that level of is acceptable, then the fact that we're not getting the high response rates is okay, as long as your replacement method is sound.
The second thing, real quick. Now I forgot how to phrase it. How much of the difficulty with polls can be attributed to the fact that journalists are generally mathematically illiterate, as is a large percentage of the American population? Sorry, guys, not us.
Well, it's funny. I used to, when I talk to reporters over the years, and they come to me, and I start saying, like I said, look, you didn't go into that profession because you scored a 5 on your AP calculus test. And I know that. So let's explain. It is difficult. It is difficult. And I've tried. That's been actually part of my mission over my career, is to educate reporters, not educate them into understanding everything about it, educating them into knowing to ask the right question of the pollster to get a sense of whether that it's accurate or not yet. So, but yeah, it's unfortunate, because as much as I say, my polls don't predict anything. They just give you what's the here and now, and you might be able to use them for a range of possibilities for the near future, but not beyond that. And it's still, the headline says, poll predicts. This poll predicts, that poll predicts. And there's nothing we can do about it. I've tried.
And with that, will we please thank Professor Murray one more time?